Okay, let's put together some things we've learned the past few days. What we want to do is to find the exact area of each of these shaded regions. So in number 1, we're trying to find the exact area of the region between the graph of f of x equals, that's e to the x, isn't it? And the x-axis on the interval -1 to 1. Now originally we found this, or we approximated this area, or an area of a similar region, by using Riemann sums with maybe 4 subintervals, 4 rectangles, right-hand endpoints, left-hand endpoints, midpoints. But we're not approximating the area anymore. We're finding the exact area. So we're using infinitely many rectangles, not just 4 or 6. But limit, remember how we did a similar problem the long way? Finding the limit as n approached infinity of the sum as I went from 1 to n of x sub I star delta x. We found actually the area underneath the curve of y equal x squared on the interval 0 to 2 or 0 to 4. But actually doing the 4-step process of finding the limit of sum. That was quite lengthy. But we don't have to do that anymore. The limit of a sum is a definite integral. Definite integral from what? -1 to 1. And what is my f of x in this problem? It's e to the x. So, to find this shaded region, area of the shaded region, I just need to evaluate the definite integral from -1 to 1 of e to the x dx. That's what this notation means. But we learned the shortcut. We don't actually have to do the work of finding the limit of a sum. We can use fundamental theorem of calculus. That tells us to anti-differentiate e to the x. So the antiderivative of e to the x is e to the x. And evaluate that at the endpoints. So I get e to the 1 minus e to the -1. So that's e minus 1 over e to the 1. Remember, e to the -1 is 1 over e to the 1. That's e minus 1 over e. You could get a decimal for that, but that's the area of this shaded region. If you've got a question, you can shoot me an email. Or if you're 11:30 class, shoot Chase or Nathan an email. Okay. Everybody try to do number 2 on your own. Find the area of that shaded region. You have to write a definite integral or integrals, right? How many of you wrote this? Definite integral from -pi over 2 to pi of cosine x. Is that going to give me the right answer? That's a common answer. I hear some of you saying yes, I hear some of you saying no. What might be the problem with this? Look at my region. Part of the graph's above the x-axis, but part of the graph's below. Remember, if the graph drops below the x-axis, the definite integral will give us the net area, the area above the axis minus the area below the x-axis. Remember f of x sub I stars for this region right here. If I look at a little typical rectangle in this region, f of x sub I star is going to be negative. So when I add f of x sub I star times delta x for this region, add those up, you're going to get a negative. So that's going to really subtract away from all this area over here. So this isn't going to give me the right answer. What will give me the right answer? The definite integral from negative pi over 2 to pi over 2 of cosine x plus the absolute value of the definite integral from pi over 2 to pi of cosine x. I know that the definite integral from pi over 2 to pi is going to be negative because our region drops below the x-axis. So to fix that, I can take the absolute value. Okay, let's evaluate these definite integrals. What's an antiderivative of cosine x? What do you differentiate to get cosine x? Sine x, right? I don't write the integral symbol anymore because I've anti-differentiated. Once you find the antiderivative, you don't write the integral symbol anymore. Okay, so I've got cosine of pi over 2, sine of pi over 2, minus sine of negative pi over 2, plus absolute value of sine pi minus sine pi over 2. Sine pi over 2 is 1. Sine negative pi over 2 is negative 1. Sine pi is 0. Sine pi over 2 is 1. So I get 1 plus 1 plus 1, or 3. 3 is the area of this total area of these shaded regions. If I wanted to carpet what's shaded here, it doesn't matter if the region you want to carpet is above the x-axis or below the x-axis. Area is always positive, right? What would we have gotten if we'd evaluated this definite integral from negative pi over 2 to pi? Well, the antiderivative of cosine is sine. So we would have gotten sine pi minus sine negative pi over 2. That's going to be 0 minus a negative 1, or 1. Okay? Now that makes sense because there's 1 unit of area right there. There's 1 unit of area right here. There's 1 unit of area right there. In all, there's what? 3 units of area. But how many more units above the x-axis than there are below? Well, there are 2 above, there's 1 below. So there's 1 more unit above than below. And that's what this 1 means. The answer to this problem, number 2, is 3. But it should make sense to you why the definite integral from negative pi over 2 to pi of cosine x dx is 1. Okay, let's do this last problem. Find this area of this shaded region. Everybody write down the definite interval that you would evaluate. Write down the definite interval that you would evaluate. We're partitioning the interval what? 1/2 to 2. My function's 1 over x. So the definite integral from 1/2 to 2 of 1 over x dx is going to give us this exact area of the shaded region. Antiderivative of 1 over x is natural log absolute value of x. I evaluate that from 1/2 to 2. So I get natural log 2 minus natural log of 1/2. You could get that in decimal. Now, after you might review a little bit of Cal 1 when you start Cal 2, but the first thing you'll do in Cal 2, regular material, section 6.1, and you'll just be extending these ideas today. You'll be finding things like you'll have an f of x and a g of x, and you'll be finding the area between those two curves. So let me give you a little heads up. You'll draw a typical rectangle, and the rectangle that falls between would be there. Well, what's the height of this rectangle? If this is a x sub I star here, in that I subinterval, the height of my ith rectangle is top minus bottom, f of x sub I star minus g of x sub I star. That's the height of my typical rectangle. So the width is delta x. So my area is just going to be the limit as n approaches infinity of the sum as I goes from 1 to n of the height, which would be f of x sub I star minus g of x sub I star times delta x. But that is what? That's the definite integral of f of x minus g of x dx on some interval, let's say a to b. Say we're trying to find the area between a and b. So that'd be the definite integral from a to b. That just gives you a heads up of where you're headed in Cal 2 on this material.